Hi there. It's time to make another great graph and to look for some relationships and understanding of the simulation that we just completed. If you have run the simulation correctly, you should have gotten the following numbers. And you can enter those. I'm sure you will do that. And if you take a look at this data before we even make the graph, what you can see is that as we increase the mass, the velocity does not move. It stays the same at 22.14. I'm sure you found the same. Maybe you were a little bit surprised about that, and that's quite reasonable. The reason the velocity does not change is in this simulation, we assume there is no friction. And if you remember from Unit 2, which I know is a while ago, but in Unit 2, we talked about when there is no friction, all things fall at the same rate. So independent of the mass, because we started at the same height, we always started at 25 meters, independent of the mass, the velocity will always be the same at the bottom of the ramp. Okay, so that explains why this velocity doesn't change. That's a pretty reasonable assumption here because this sledding hill might be quite icy. And then indeed, there will be very little friction, so it's not a bad assumption in this case. However, in the real world, there is friction and the velocity will be affected by that friction. Okay, so that's a little bit of an explanation of why the velocity remains constant even when we increase the mass. Something is counterintuitive and it's very difficult for our brains to train to think that way. Okay, so let's make the graph, no further ado. Follow along and then I'll show you exactly how I want you to do the final graph. So again, we highlight all the data here just to show you, and then we go to Insert, Chart, and then we get this graph. It automatically defaults to a scatter plot, which is nice. So you see here that the blue data, the data for the velocity, stays the same. Actually, it stays at the bottom here because these numbers are so small compared to the values of the kinetic energy. One trick to change that is what I'm going to show you. So you're going to then to customize, you're going to go to series, you're going to go to velocity, and let's just put the velocity on the right axis. All right. Now we can see this is the velocity, so it stays absolutely constant. All right. Now we already talked about that, so I don't want us to get too hung up to that. But that is a way, if you ever make graphs in the future, for you to see and split out those numbers because the velocity is so much smaller. But you can put two data sets on a single graph and get a very clear view of what that looks like. All right. You can leave it like this, although you actually kind of need to put the axis here. I'm going to make our life a little bit easier. All right. So maybe this is the easiest way of doing it. I'm just going to delete this graph. And instead, what I really want to take a look at is the kinetic energy, how that varies when the mass varies. So I'm just going to select this data. I need to first select that, and then I hold the Control button, and then I select this as well. And then I'm going to go to Insert Chart. And now I just get the straight kinetic energy versus mass chart. All right. So we can see here as the mass increases, the kinetic energy also increases. Now, I wanted to show you, because you guys are becoming so good at making graphs, another little trick here that you can do. So let's go to the Customize. And then I want you to go to Series. And then scroll down, and then we're going to put in a trend line. All right. The trend line is a line that basically automatically fits a line to your data. So we're going to click that, and you see I get this perfect line here. Now, since this is perfect data, because it's a simulation, the dots all fall perfectly on this graph. Okay, but it gives us a clear view of this. This is an absolute straight line. It's a linear relationship. As the mass doubles, right, my kinetic energy doubles. As the mass triples, my kinetic energy triples. If my mass quadruples, my kinetic energy quadruples, and so on. All right, so that's your graph. So take a moment. So you go through the three dots. Copy the chart and then paste that into your, right there. Just go to link to spreadsheet, paste in there, and put that in there. Okay, thank you.